Thank you very much. It's a pleasure to be here. It's very impressive to see what the foundation has put up already and what kind of discourse is starting to happen here. I would like to talk about paradigm to practice. So are we on the verge of actually a new culture of building? Are we on the verge of a digital building culture? And I believe so. As you know, the world is changing. We are challenged with rapid societal challenges which are induced by fast technological changes. We heard the discussion just before. Now, what is maybe a bit under the radar is also that the fact that production is changing, the way we make things, the way we do things. We heard a lot about, fourth industrial revolution. We heard about many of those changes, 3D printing, additive manufacturing, robotics, but somehow it's always happening a bit on the side. So the question that I would like to put on the table today is, will the way that we actually build, will that also change? And the answer that I would like to give is yes. The way that we build will change, and it is actually already changing. So if you, for example, search robotic fabrication in architecture today, this is roughly the Google hits that you get. And you see that worldwide, universities, architecture students, design enthusiasts are actually engaging directly with technology, with robotic technology, to change the way that we designed and build today. In Switzerland, I have the pleasure to direct the NCCR, that stands for National Center of Competence in Research on Digital Fabrication. It's an initiative which we built up, which stemmed from our research, that brings together different experts from various disciplines that contribute to an interdisciplinary research setting. So we have material scientists, we have roboticists, we have structural engineers, we have environmental people, different people that work together with architects to see how we can promote and actually proactively cultivate such a new digital building culture. But what I would like to do with you here is basically bring you back a bit in time, see where it all started, where the motivation came from this development, so that you can share this with me. So we started our research at ETH Zurich in 2005, and this was the first setup which we built. A simple robotic arm, like you find them in thousands in, for example, the car manufacturing industry. But what was special is that that robot was set up in an architecture faculty, which hadn't been done up to that moment. And why did we do that? Why did we bring a robot to an architecture faculty in the first place? Now, if you want to build buildings and you want to bring that together with the digital, you need a way to access the materiality of architecture, or its materialization actually. And how do you do that? There is no machine that builds architecture. It simply doesn't exist. There are machine-specific tools that build you some specialized parts, but no machine that actually assembles architecture. And if you look at architecture all around you, basically architecture is about assembling parts to form spaces which we all love to then inhabit and take part in our kind of social lives. Now, since there was no such machine, we reverted to the robot. And the robot is just a generic machine which can do many things. So the interesting thing about the robot is actually that it does not have a hand. So it's basically just an arm that can move in space. So now, as an architect, you need to think about what his tool shall actually do. So what's the purpose of this tool? How do you want to manipulate matter? How do you want to sense reality? How do you want to interact with the world? And that generic potential is what we find still very interesting in the concept of robotics in the design of architecture. So from this initial setup, we formulated a hypothesis. We wanted to bring together computation, material, by fabrication. And by bringing those together, Our hypothesis is that materiality, as we now know it, wood is wood, concrete is concrete, etc., and you can treat it in certain ways, actually shifts to what we then called digital materiality. And the digital materiality is a materiality that becomes informed. So in this case, for example, this concrete wall is not an ordinary concrete wall. It's made out of concrete, yes, but you see it is as much digitally informed as it is physically concrete. Then it leads us to a rethinking on how we construct. So if we start to build with these digital tools, we do not construct the same way. So education actually needs to change, and we need to think about new material and constructive systems. Also, it leads us to the design of processes. So as architects now, we are trained to largely think in plans, sections, possibly 3D models, which are relatively static, and then through iterations come to a final design. Now, with digital tools, we have the possibility to encode behavior as part of a design. And we can thus shift certain decisions, basically create an openness to an adaptive design in such a way of conceiving architecture. I'll illustrate this later. And last but not least, and that's a high motivation for me and my fellow team, of course, the digital is also prone to lead to more abstraction in life. We always look just at screens, etc. But what is nice with this digital materiality is that actually the sensuality of material is enhanced. So whatever we do physically, it's actually exposed more through the digital control of these processes. So let me show you some early work. In the beginning, we used, and we actually still use, robots in prefabrication. So in this case, we designed a facade of a vineyard building in Switzerland, and this is how it looks. So you see kind of oversized grapes in this brick facade appearing, and this is how it was produced. You see the robot grips individual stones, puts glue precisely where this needs to be put on the stones. And positions them. And what you can recognize here and in the next picture is that each of these stones is just slightly rotated, up to 17 degrees in one direction or 17 degrees in the other direction. And what you saw before as this narrative of these oversized abstracted grapes is actually just the reflection of these slightly rotated stones in the daylight. So this facade constantly changes its appearance over the day. It has a plasticity, but if you go closer, the material which it is made out of, namely brick, is still very present. So the material doesn't lose its presence in this. And here is an inside view of this winery building. Now, you could also take robots on site and start to do prefabrication on site. We tested this at the Venice Biennale in 2008. So here you see a robot called Rob in a container shipped to the Biennale, and we do the production directly in front of the Swiss Pavilion, where we designed an exhibition for. So these walls here, you see they have certain features. They then form a new spatial arrangement in the pavilion to host an exhibition. Now, what is special here, and now I come to the design of processes, is that this wall here is transformed into this layout by a programmed design. So this line here, we call it the line of negotiation. It's actually a drawn line. This line was drawn because there are multiple participants in the exhibition, so we needed to shift the position of this wall up to the moment before the exhibition was actually realized. Now, depending on whether this wall was rather straight or whether it was curved, the wall started to oscillate on its own. So on its own meaning by a program. So wherever here the wall, I try to show it here, is rather straight, it starts to oscillate, and where it's curved, here for example at the ends, it oscillates. Now why did we do that? This wall was produced by about 4.5 to 5 meter long segments, and by simply curving and oscillating this wall, we actually gave a constructive meaning to this wall, meaning that each of these elements could stand on its own without further reinforcement, without anchoring. So a very simple way of creating a stable wall. At the same time, taking this liberty into the design of this installation. And here you see how it looked like, how it gained a kind of, let's say, natural, almost textile appearance, and how it stood there quite gracefully without further support or anything, because we took in the constraints and processed them as part of the design. And so we could change this wall layout up to the moment of its production. So we can take robots and prefabricate on the building site, but maybe we can also take robots, and we will see that in the future, directly onto the building site. This is a program, a research which is actually still in progress. It's called mesh mold, and you see on the right hand what it produces. It produces steel wire meshes, which are actually reinforcements for concrete walls. Now, what is special is that by a robot building this wall, you don't need any formwork to build a concrete wall, and you have design degrees of freedom. You can freely shape this wall, and you can also thin the wall out where you need it. Therefore, you can save a lot of materials, a lot of labor also, in the process of making concrete walls. Now, if you know that concrete is responsible for most of the CO2 pollution in construction, this becomes quite an important argument. And maybe the way that we build with concrete will change through such processes. Of course, we shouldn't forget the human. So a big question is, well, how is the collaboration between human, machine, and the new constructive systems? So here's how the system works. This is still from 2012. This is how we started. So basically, we extrude a spatial mesh. And this mesh, you see here that it can thin out, it can have a free form, can then be filled with concrete directly. So some of the material flows out, but most of the material actually stays. And if you attune the properties of the concrete mixture rightly to the size of the spacing of the mesh, you directly build a concrete wall. This wall can then be finished manually. So this is went one too fast. Can then be finished manually, so this is a collaborative process. And at the current stage, we're now testing the system at a full building scale. This is a building that's actually the only work that I showed, which we did in the architecture office. So that's a building which we designed in the office, onto which you can plug multiple other buildings to test new building materials, new energy efficient systems, etc. So on this building, we'll now build this small building, and you see in this first floor here that there will be a wall built with the system. This is roughly how the wall will look like. It's optimized for structural performance, and it supports the entire upper 2 stories. So this is the proof that these systems can actually work on a load-bearing scale. Here the robot will be repositioned at different instances and build this continuous mesh. And the construction of this has actually just started last week. So here you see how that looks like. Now we can debate, what is the human now doing here? What is his role? Watching robots? How many humans versus how many robots? But still, it is interesting. I mean, this research is now about 1 decade old, and we already transgressed with the help also of roboticist colleagues and material scientist colleagues to a state where we can demonstrate it on a building site. So if the future is now, yes, it is now. It's really happening as we speak. So maybe in the future we will see these kind of peers of humans which are robotic, and this larger question on who controls whom is obviously out to be discussed, and also the question of labor shortage, etc. But I want to point your attention more on the possibilities that this brings. So in this case, as I've shown earlier, you can really efficiently produce these walls. You don't have to follow the straight walls that stem from the old industrial age of producing straight formwork in a repeated manner. So here, form doesn't cost anything. That's a completely new paradigm. How do we deal with this design-wise, but also integrating other disciplines like structural engineering, etc. And how can we use that in a material efficient way, but hopefully also create really livable spaces with these new technologies. Now, I've shown how robots can go from the factory up to the site, but maybe robots in the future will look different. So here is an experiment which we did also with a roboticist colleague from ETH Zurich, and we built an installation by a flying machine. And here, these machines, they cooperatively build up a 6-meter high tower. And this tower, this installation object, is only built by this machine. So no human touches this artifact while it's being built. And there's also no scaffolding needed, no further kind of work. It's just the material being brought to its final destination by the machines. Now, in this case, I make a small loop to kind of an urbanist debate. We also did a speculative project on the occasion of this exhibition project. We actually said, well, one of these blocks is not just a block of foam, which is flown there by these quadcopters, but it is actually a 3-story unit, which can be outbuilt for plenty of different purposes. So from a cinema, shopping mall, down to different habitation configurations, hospitals, etc., civic services. And we kind of conceived this object as a provocation to say, could the city be an object? And we placed this object in a region in France that is called Meuse. It's in the so-called Diagonale de Vide, so that's the region in France which has the least population density. But as an interesting matter of fact, exactly in this area, there is a TGV station which had been put there by political reasons. So actually this area in the middle of nowhere is connected by train in less than an hour to Paris. So here the idea is, could we not build a city for 30,000 inhabitants there as an object? We use it. After a certain use time, we build it back, and that was the intervention of the human at this point. And we leverage it, we directly connect it to the infrastructure which is built there. Then this city, and just to give you an idea of the scale, has these double-story park rings, each 10 meter high. If you walk around the perimeter, it's 1 kilometer of a stroll. It's fully pedestrian. It's fully operated with sustainable energy. So if there's an investor in here who would like to build this, please reach out to us. But let me get back to the topic of my talk. Here you see how it is built. Please note that this drop that you've been seeing, this is the most precise way to position an element, because you don't create turbulences that you would create when you would approach slowly. And here you can see how this tower builds up almost magically without almost visible interaction, really by the material just being deposited by this swarm of machines. So not only collaboration of humans, so not only collaborations of humans and machines are a big topic, but also the collaboration and cooperation between machines actually. Are they specialized, different trades? Do they cooperate? How do they do that? How do they then interact with humans? So there's an entire new ecology, if I may say so, with these digital tools to be expected. Now, a very small and moderate project, but just to kind of open up a bit the spectrum of thought is a recent installation which we did. And here a robot does nothing else than manipulating one particle by actually suspending it in space. So you see this white point, and this white point is actually held in place by ultrasound waves which you cannot hear. Then you take it out, if you wish. So with this I would like to show that the relation also between machines and material is starting to change. And so we have an entire chain of changes and possible mutual interactions, which I think is also a fantastic field to explore. I think beyond just problem solving, it could create new realities which are also a delightful part of human life. Good, so now to what degree is this realistic? Can this be used? Will we see this soon in construction? The biggest project which we realized so far is a roof structure. So it's not an entire building yet, but we're working on this at the small scale. And this roof structure is called the sequential roof. It's our new institute building's roof. So now the National Center of Competence in Research for Digital Fabrication has its home here. Our offices are here. And it's a big communal building. And the roof, here you see a plan, although it was never designed on a plan. The roof acts again like a textile. You see how it looks like a textile which pulls together at certain instances, tears apart at other instances. These are all certain technical challenges which need to be met, let's say the fenestration where it lightens up, certain ducts which need to pass through the roof, the support columns. So it is a design that behaves in order to fulfill something. And that's the message that I would like to get through, how it might also change the reality on how we design as architects in the future. Here you see how it's built. It's made out of very simple, standard, ordinary, I could say, timber slats. And these slats are nailed together in this case to form these 15-meter long beams, which are then assembled. You see how these beams are built up. It's a relatively simple build-up. Now, what I've shown before in the plan, you see how the digital, in this case, not only provides for the form and the assembly information of these beams, but also provides a system which can integrate all the necessities within the form of these beams. And so then the digital model is only a representation of the design, which is actually by a large part, not only, but by a large part, programmed. So what does it mean if architects in the future program? It's a difficult question because it's not so easy to program, it's not so easy accessible, it's maybe not so visual. Yet at the same time, for all those that have done some programming with, let's say, within a design context, it can also be very enlightening, I could say, to actually have the feedback, always the visual feedback of, let's say, the rules that you give the computer. But that's going to be a larger cultural question in architectural education, if program can be part of it. Then, of course, computation solves a lot of nitty-gritty details. This, for example, it would be a nightmare for every human to calculate this or to execute this, because here every nail must ensure that it doesn't hit another nail, and there need to be a sufficient number of nails in every node to fulfill the static requirements, which are calculated on each of those nodes. So we start to enter an area where also engineers cannot control every instance of such a building. They can only do it by digital tools, and therefore they need to design the algorithms. Then how was this roof built? Here, sorry, it's a bit of a promo video by a contractor, but here a contractor got excited about the project, and he actually invested in a robotic facility. So he built this facility for this project. Here you see the robot cutting the slats, nailing the slat. Here this nailing pattern, which I've been presenting you before. And what you end up with is really a kind of a 3D printed truss at 1-to-1 scale, only that here it's not powder, which is binded together by glue, but it's really slats with nails that are put together at the full building scale with real building materials. And of course, the materiality of the timber is important for the quality of the space in which we all live and now actually collaborate really well. Below here is a new laboratory. Here we take basically a step out of the factory with cranes to a factory which is very open, very flexible space. You can do everything you want in here, and the robots just come and help to assist you wherever you need them. That's kind of a new paradigm which we're testing out here. And we're doing this with structures like this, where we test how two robots, for example, can cooperate to build up such a structure without, again, further scaffolding. Now, to end up, I would like to show you one more project, and I'm a bit over time, so I'm going to go fast. The quest of rock print, and that's a project which we've done together with the self-assembly lab of MIT, was how could we build in a very sustainable way with very ordinary matter? In this case, gravel, a material which you find everywhere. And knowing that the main loads of buildings are actually in the floor slabs, could we use an effect called jamming, where if you put a lot of weight on gravel, the gravel actually for a moment is stable, doesn't move anymore, cannot go away. And when you lift off the floor slab, it actually goes back to its original state and becomes gravel again. So we have fully renewable resources. Now there is a trick to it. If you do it only with gravel, it doesn't work. But if you combine it with string, it actually does, if you do it in the right way. So what we've done here is we built up layers of gravel followed by layers of string subsequently in a container of 4-meter height. So this entire volume weighs around 2 tons. Now you can take off the perimeter of this box. And the only reason why this is sticking is because it's lightweight gravel, because the floor of the Chicago Architecture Biennale couldn't support full gravel. And then you can unearth the structure that you've built inside by the network of the strings. And this is how it looked like. So the mass on top is actually stabilizing the rather slim legs below. So there is no steel in there, there is no glue reinforcement whatsoever. You see the kind of new materiality that emerges, so cherish gravel, right, as a building material. So I think the low and the high tech are not mutually exclusive. I think they can come together in very nice ways. And the proof of concept that this is fully reversible, we did at the finissage. So here you see Petros, the project leader, actually pulling out the string. This is the aesthetics of it. So everyone who So everyone who likes performance art is also liking these new technologies. Good, and with this I would like to end. So basically we're back to the raw materials where we started with, and I think we're at a very exciting moment in time. Probably we go towards a new digital building culture, can be in the very small, could also be in the very large scale of new cities. Thank you very much for your attention.